Today's video lesson is on surface areas of pyramids and cones. Objective to find the surface area of a pyramid and a cone. So you should understand to find the surface area of a three-dimensional figure, which is a polyhedron. You can find the sum of the areas of all the surfaces of the figure. So in the previous video lesson we did surface area, lateral area of prisms and cylinders. So now we're going to go with surface areas and lateral areas of pyramids and cones. So a pyramid is a polyhedron where all the lateral faces meet at a vertex and there's only one base. The altitude of the hexagonal pyramid in the diagram to the right is the distance from the vertex to the middle of the base or center of the base. You're going to have a lateral edge, you're going to have a base edge and a lateral face. Okay, you're also going to have a slant height and a height. So remember, in the prisms and cylinders, the height between the bases was the height of the prism or cylinder. Here, the height of the polyhedron, if it's a pyramid or cone, will be from the vertex to the center of the base. Okay, remember the height is also can be called an altitude, and remember the base and altitude are always going to be perpendicular. Okay, well, not always, but in order to multiply to find area, like I said in class, area, base times height, base and height always have to be perpendicular in order to multiply them. And you should notice that the slant height is actually the altitude of the lateral face, which is a triangle. So the altitude of the triangle, why do you need the slant height? Because the area of a triangle is half times base times height. So we're going to get into some formulas and some examples. So just like with surface area of prisms and cylinders, you have lateral area. Okay, the lateral area here is half times the perimeter times the slant. Okay, L is the slant. So the lateral area is coming from the area of all four, or it doesn't matter, all n sides of the lateral faces. So those are triangles. So half PL is coming from the area formula for a triangle. So things that we need to note. That, again, P is the perimeter of the base. L is your slant height. Okay, it's your slant height. So the slant height is actually the altitude of the triangle face, the triangle lateral face. So surface area is equal to your lateral area plus B, where if it was a prism or cylinder it was 2B because you had two bases. With pyramids and cones you have one base. So capital B is the area of the base. So in these types of problems we might have a slant height of a pyramid or a cone. That's not given, therefore we're going to have to calculate it. So a little foreshadowing, if you don't have your slant height, I'm highlighting it here. You should know that, okay, if I don't have a slant height, I'm going to have to find it. How am I going to find it? 9 times 10, Pythagorean theorem. Okay, you could also use probably trigonometry if you choose to do so, but that's a little bit more work. So if you don't have slant height, you're probably going to have to use Pythagorean theorem to find the slant, which is, in this dark triangle that I highlighted, is the hypotenuse. So let's do this. So what's the surface area of the hexagonal pyramid? Well, lateral area equals half PL. Okay, where P is going to be the perimeter of the hexagon. Well, the perimeter of the hexagon, it's going to be a regular hexagon. Okay, so hexagon has 6 sides, so the perimeter is 36. The slant height is 9. So the slant height is the altitude of the triangle on the lateral face. So my lateral area is equal to half of 36 times 9. So if we have half of 36 times 9, we get 162. So the lateral area is equal to 162 inches squared. Since we're dealing with area, it's unit squared. Now, if I want my surface area, the surface area is equal to the lateral area plus capital B. Well, capital B is area of a regular hexagon. Well, how do you find area of a regular hexagon? Well, so therefore, capital B, area of a regular hexagon, is half times the apothem times the perimeter, which is equal to area equals capital B is half times the apothem times number of sides times your side length. So capital B is equal to half. My apothem given is 3 radical 3. Number of sides in the hexagon is 6, and side length is 6. So I have 6 times 6 is 36. So half of 36 is 18. 18 times 3 is 54. So it's 54 square root 3 is my area of the base. Now we can convert this to a decimal equivalent, which is about 93.5. So this is about 93.5. So my surface area is equal to 162 plus 54 radical 3. That's the exact answer. Okay, make sure you understand that you should be able to give exact answers and rounded answers. The reason why we can't add 162 plus 54 radical 3 is because they're not like terms. So if I want the rounded answer, the surface area would be 162 plus 93.5. So if I have plus 162, I get 255.5. So the surface area is about 255.5 inches squared. So we have the exact answer, 162 plus 54 radical 3, and we have the rounded answer, 162 plus 93.5. Okay, where do we get 93.5? We just estimated 54 radical 3 to the nearest tenth. And there we go. There's the lateral and surface area of the polyhedron, which is a pyramid, in this case, with a hexagonal base. So let's try this example. We have a square pyramid. That means the base is a square. Okay, let's draw it. Our square pyramid. Okay, a base edges of 5, so these are 5, 5, 5, and 5, and a slant height of 3. So let's draw in our slant height. So let's draw in our slant height. Remember, the slant height will be the altitude of the triangle on the lateral face. And the slant height, okay, this dotted line is 3. I want the surface area of this square pyramid. Well, I need to find the lateral, which is half times the perimeter times the slant. Okay, P is the perimeter of the base, which is a square. I need the perimeter of the square. Well, the perimeter of the square is 20. Add up all your sides. L, the slant height, okay, slant height is 3, because that's given. So my lateral area, plug in the numbers, substitute in, is half times the perimeter times the slant. Half of 20 is 10, 10 times 3 is 30. So my lateral area is 30 meters squared. So now that I have my lateral, I can find the surface area, which is my lateral area plus capital B. Capital B is the area of a square. So capital B is side squared, which is 5 squared, which is 25. So my surface area is 30 plus 25. So my surface area, add them up, is 55 meters squared. These are pretty easy because I give you your slant height. So let's try a little more challenging problem where I don't give you your slant, I give you the altitude. The altitude goes from the vertex to the center of the base. So C to A, I need to find. Okay, we're going to assume all bases that I teach in this unit, or not in this unit, all bases in this video lesson are regular. Okay, so all bases are regular when I'm dealing with pyramids. So my lateral area equals half PL. Well, perimeter is going to be 30 times 4, which is 120 meters squared. Okay. L. I don't have L. It's missing. Here is L. L is right there. But you should know that I have a right triangle with an 36.4, and this is not 30, so well, let me fix this. This is, so let's do, here we go. Let's be a little more neat here. So B, A, C, 90, this is 36.4. Here's my L, I don't have it. C to A, okay, C to A is not 30, it's going to be half of 30, which is 15. Therefore, I have 36.4 squared plus 15 squared equals L squared. So 36.4 squared plus 15 squared is 1549.96. This 0.96 equals L squared. So I take the square root. So the square root of 1549.96 equals L. Let's round to the nearest hundredth. So the square root of our answer is 39.4. So L is about 39.4. So 39.4, it makes sense because our hypotenuse is always the longest side of a right triangle. Again, don't forget your triangle rules. So L is 39.4. So now I can find my lateral area, which is half times 120 times 39.4. So half of 120 is 60, so 60 times 39.4 is 2364. So the lateral area is 2364 meters squared. So all that work just to get my slant height and also to get my lateral area. Again, just reinforcing Pythagorean theorem to solve for a missing side in a right triangle when you're given two sides. Now I can find my surface area, which is my lateral plus capital B. Capital B is going to be 30 squared. So when I have 30 squared, I get 900. So now I have 2364 plus 900. So 2364, and I get 3264. So get 3264 meters squared is my surface area. Let's try another one. Okay, again, assume all your bases in a pyramid are regular. So lateral area is half PL. Well, the perimeter is 36 times, that's a hexagon, 6. So 36 times 6 is 216. So that's my perimeter. My slant the slant is unknown, but I can highlight what I need to do. So if I take my blue line and highlight that I need to find this right triangle, okay? So if I highlight this right triangle, seems my pen is giving me some problems here. So if I label A, B, C, so here's A, B, C, okay? A to B is 42, B to C is 18 radical 3. So I need to find L, so Pythagorean theorem, because I have two given sides and a missing side in a right triangle, so I have 42 squared plus 18 radical 3 squared equals L squared. So I have 42 squared plus 18 radical 3 squared, which is 2736. So I have 2736 equals L squared. Square root of 2736 equals L. So L, if I take the square root, will be 12 square root 19. 12 square root 19 is the slant exact. If I want to round it, it's 52.3. 52.3. So my lateral area equals half perimeter 216 times 12 radical 19. So 216 times a half times 12 radical 19. And I get 5649.1. So using Pythagorean theorem to solve for L, I now have my lateral area. So I need my surface area. Surface area is going to be my lateral area plus capital B. Okay, capital B is area of a regular hexagon. So capital B is half times the apothem times number of side times side length. So capital B is half times the apothem. The apothem is 18 radical 3 times number of sides times my side length, which is 36. So my capital B is a half times 6 times 36 times 18 radical 3. So capital B is 3367.1. 3367.1. So my surface area is lateral, which is 5649.1 plus 3367.1. So 3367.1 plus 5649.1. We get 9016.2. So all this is 9016.2 feet squared. And that's the surface area. This is a good problem. This is working with radicals. Second part of this video lesson is the surface area and lateral area of a cone. So cone is similar to a pyramid, whereas the vertex down to the center of the base is your altitude. You still have a slant height, and the base here is a circle. So if your base is a circle, you can either have a cone or a cylinder. If it's a polygon, it's either a pyramid or a prism. And you can read this over. We're going to go over it during class. So you have lateral and surface area of cones. Lateral area is half times 2 pi r times L, or it's basically pi r L. So notice here that if it's half 2 pi r, a half times 2 is 1, therefore what you're left with is just pi r L. So you don't even need to remember this formula. I would just remember this one. Pi r L is lateral area. Surface area is equal to lateral plus capital B. Well, capital B is pi r squared. So your surface area is pi r L plus pi r squared. Because pi r squared is the area of your base, and your base is a circle. Area formula for a circle is pi r squared. So let's try the surface area of the cone in terms of pi. That means you don't use pi in your calculator. So my lateral area, okay, remember a lateral area is just pi r L, is just, again, pi r L. So r is 15, slant is 25, so lateral area is pi 15 times 25. So 15 times 25 is 375 pi. So lateral area is 375 pi centimeters squared. The surface area is lateral area plus B. Surface area equals, well, the lateral is 375 pi plus pi r squared. So we have 370 pi plus pi r is 15 squared. So 15 squared is 225 pi. So we have 375 pi plus 225 pi. Remember, when it's in terms of pi, you don't use pi at all in the calculator. You don't use 3.14 in the calculator. You don't use the symbol pi in the calculator to get your answers. So when you add up 375 plus 225, 600 pi. So all of this is equal to 600 pi centimeters squared, and that's your surface area. That's 0. It's not an 8. So you have a radius of 16. You have a slant of 28. So I want the surface area. So lateral area is just pi r L. So I have pi 16 times 28. So 16 times 28, which is 448 pi. So 448 pi meters squared is my lateral area. Surface area is lateral area plus pi r squared. So 448 pi plus pi radius squared. Well, we have 16 squared. So 16 squared is 256. So I have 448 pi plus 256 pi. So I have 256 pi and 448. We get 704 pi meters squared is my surface area of this cone. So you can do these problems without a diagram if you want to know what this diagram looks like of this cone. So I'll draw this to the best of my abilities. So here is your cone. I'll draw in the radius with the dark red. So my radius is 16 and the slant from A to B is 28. So that's what this looks like. Here's that type of cone, not drawn to scale, obviously. So let's do this lateral and surface area. So my lateral area is pi RL. Okay, notice that I don't have my slant, so I'm going to label my triangle A, B, C. This is 40, this is 45. So what I have here is a right triangle. I'll redraw it right here. So here's C, here's B, here's A, 45, and this is 40. The reason why C to B is 40 because the diameter is 80, the radius is half of it, so half of 80 is 40. So I need my slant. So how do I find my slant? Pythagorean theorem. 45 squared plus 40 squared equals L squared. So 45 squared plus 40 squared is 3625. So 3625 equals L squared. Square root that. So if I take the square root, I get 60.2. So L is 60.2. It's actually 5 root 145, which is the same as it was 5 root 145 if you wanted the exact slant. So now I can find my lateral area. So my lateral is pi, radius is 40, my slant is 60.2. And leave it in terms of pi. So 40 times 60.2, 2408. So my lateral area is 240808 pi millimeters squared. So my surface area is equal to 2408 pi plus pi r squared. So 2408 pi plus pi radius is 40 squared, which is 1600. So I have 2408 pi plus 1600 pi. So 1600 and 2408 is 4008. So I have 4008 pi millimeters squared, and this is my surface area. So there's the video lesson for today. Sorry for the delay in my pen when I was writing. If you have any questions, see me during class, send me an email. Don't forget to do your Math Excel, and have a good night.